This is our final big data presentation, and we focused on H&M personalized recommendations. Our team consists of Janvier, Summer, and Sherraina. A little bit of introduction. H&M is one of the largest clothing retailers in the world. They only come second to Zara. However, they're lacking in their online presence. And so for our project, we designed a data pipeline with an integration of Hive, PySpark, AWS, RDS, and Tableau to better manage their unstructured data. And we also built an ALS model and PySpark to help H&M make better recommendations to their online customer base. Our data set is a 38.5 gigabyte with images, customers, articles, and historical transactions table. And in the end, we made recommendations based on customer purchase history and images. And now I'll pass it on to Janvier to talk about the data sets.
Oh, thank you, Sherraina. About our data set containing 3 tables and 1 further containing images. For the articles, which articles containing the information about the products, you had more than 100,000 unique products, and it contained all the information about those products. We also had the customer table, which contained about 1.4 million distinct customers, and the contained information about those customers. And we also had this very important table, which contained the historical transaction or historical purchases of the customers. And it contained around 32 million transactions. And the images weighed about 20 GB and pressed in subfolders grouped by the article ID or product ID. Moving next to the pipeline. For the pipeline, we tried a lot of activities with the main, basically with the goal of getting the data ready for the analytics, but also for the purpose of exploring the interoperability between different big data tools, big data management tools. The main that we did is mentioned on the right side, but we tried a lot different data loading method, including loading directly the data from local PC to RDS. That was about the tables, which took more than 24 hours, and it didn't actually succeed. We decided to halt the process. And we also tried to load the data from S3 to RDS. That also didn't fully success. But the main process is loading the data from that we followed was loading the data from S3, from local to S3, from S3 to Hive, and from Hive to RDS and Hub, as we are going to explain it here, as it is explained by the graph here. So after loading the data from local PC to S3, we took the images on S3, and we transferred the articles, customers, and transaction data into Hive. And then from Hive, we had 2 connections from Hive. One was we exported the data from Hive to RDS using Scope. And we also, on the other hand, connected our analytics tools to Hive through Jupyter Hub. Think about the RDS. We exported the Hive tables into RDS to explore, as I said before, interoperability between different tools, but also to have the data available to the source, to the tools where we need to we needed to use for the building the dashboard. So we needed the consistent sources which are not affected by the instance termination. And coming back to the Jupyter Hub, we made the data available for the analytics, and we used the Jupyter Hub. And then in the Jupyter Hub, we used PySpark and Spark SQL for data handling and manipulation. to get the data ready for the analytics, where we build two recommendation solutions, including using Emory ARS and cosine similarity. As Summer will explore, we'll talk more about this. And Summer, I welcome you to talk about the analytics with it.
Thank you, Janvier. Now I will just talk about how we get connected from AWS RDS and we come up with this Tableau dashboard. So quickly about this left side, which is mainly about the customer for H&M, we can see like more than 90% of the total customer are actually active club member, which is very impressive. And about the age distribution of the customer, we can infer that the main customer base is between 21 years old to all the way to like 30 years old. For this age group, I think price and the diversity of the garment choice are their pinpoints. And there is also small peak around age 50. So like they probably choose H&M's products because of its comfort and to keep up with the fashion trend. Going to the right side, this is the products information. We can see that H&M owns more than 100,000 clothes, and the upper body garment is the most popular one. We can use this small dashboard to explore different product categories like group type, graphical appearance, and section, and will be updated accordingly. We can also see that black, white, and blue are the most popular color, which is very intuitive to us. So that's pretty much about the report. And now I will move on to the recommendations we built. We built two recommendation models. One is based on the training data set we have, and the other is built on the images. So first, about the ALS model, this is a built-in Apache algorithm. We choose it because it's perfect for large-scale collaborative filtering problems. It made automatic prediction about the interest of a user by collecting the preferences from many other users. And we use count per customer, per product as the rating, and apply our data into the matrix factorization algorithm as this graph shown here. And secondly, let's move on to the image recommendation. We use exception for the image feature extraction, and we use cosine similarity to calculate the score and to give the recommendation for our users. And here's the insight we can get from our model. Based on the ALS model we have, we can get this list of all the articles that we can recommend for those customer ID that's provided in the training set. And also for the images prediction, we can use cosine similarity. And here is the top 12 products that are most similar to the queried images we have here. That's pretty much about our model. And I will pass it on to Sherraina to talk about our SWOT analysis and the conclusion we have.
Thank you, Summer. So our SWOT analysis of our model, some strength. We streamline customer product search, and from this, we understand the customer characteristics better. Some weaknesses is that our data is not in real time and there's limited computational resources. Some opportunities that we can see is to make more advanced algorithms, and we have that high quality image data set, which can be explored further. And there's possibilities of machine learning ops. And some threats are the harsh online competitions from Shein, Zara, and ASOS, and customer behavior is unpredictable. So conclusions, the pipeline that we built should be applicable to other scale businesses as well. And we hope it added the personalized values to their existing recommendation system. And we recommend H&M to switch to HDFS for data management, if not already. And the future application is to really integrate it into a recommendation interface. And then users would have the option to filter out any number of end products, and N could be all the way from 0 to infinite. Thank you so much for listening to our presentation.